Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we said that hypothesis testing is about asking the question, would this result be rare if the null hypothesis were true? In this video, we'll apply that idea to the most common question in econometrics, which is a single regression coefficient equal to 0? We'll start by just imagining that we have a very simple model, y equals to beta null plus beta 1 x and then the error term. So technically what we're saying is in a single regression, so this coefficient beta 1, which is the most important to us, is that equal to 0 or not? Let's say that we have a sample and we run an OLS and we estimate beta 1 hat. So what you have to be aware of is that your question is not exactly about is this beta 1 hat exactly 0, okay? So this is not the kind of question we're asking. Because remember, with random data, that almost never happens. So the real question that we're asking when we're saying, like, is this coefficient equal to 0 or not, is this estimate far enough from 0 that randomness alone struggles to explain it? Okay? That's the logic of the test. Now, to make this precise, we state basically two competing stories. And the way that we write them, I'm going to highlight it for the null hypothesis. We have H null. So H for hypothesis, 0 for null. And the way that we will write it is that beta is, in our case, beta 1 is equal to 0. At the same time, we also have the competing story, which is the alternative hypothesis, which you will see in different materials written either as HA or you will either see it as H1. So any of these two denominations is completely fine. We're just referring to alternative hypothesis. And remember, H null was your null hypothesis. Now, the alternative hypothesis, you'll see beta 1 different from 0, but I'll put here in red. It can be also beta being bigger than 0, or it can also be beta 1 smaller than 0. We'll learn in another video why is it important that we know which of these alternative hypotheses we're talking about. So saying clearly, what this is doing is the null is not what we believe. It is a benchmark we are testing against. So everything that follows, keep in mind, is also conditional on that null hypothesis being true. But an estimate by itself means nothing. So this beta 1 coefficient in here, beta 1 hat, it could be that we have, let's say, a 5. Cool, impressive. It could be also completely unremarkable. So it depends on how noisy this estimate is. So the question that we ask is, how large is the estimate relative to its uncertainty? Okay. And this is why variance and standard errors are central to testing. To compare the estimate to its uncertainty, we need to form a test statistic. And conceptually, and this is what you will see, keep in mind, either with a Z or a t-test, is that your test statistic is equal to whatever numbers you get out of the estimate minus whatever you are assuming that it's true in the null hypothesis, which I'll call here the null value, divided by the standard error. Okay, because remember, we're asking how large is the estimate relative to the uncertainty. This number is literally going to tell us how many standard deviations away from zero is this estimate. Okay, so how many standard deviations away from zero? That's it. So basically, it's a distance, not a probability. Now, under the null hypothesis and under the assumptions needed for inference, again, we're referring to the Gauss-Markov assumptions, these test statistics follows a non-distribution, okay? It can be a Z distribution, though most of the times is always a T distribution that you will see. And the distribution tells us what distances are typical and what distances are rare, just as we saw in the previous videos in this playlist. So we have now everything we need to judge that extremeness, especially since we've been exposed to the idea of the p-value as well. So once we know where our t-statistic sits on that distribution, we can compute the probability of observing something this extreme, more extreme, if the null is true. And that probability is the p-value. Keep in mind, as a reminder from the previous videos, small p-values meant that it's hard to explain with randomness alone, and large p-values, well, within what randomness can generate, it's okay. Okay. Overall, the test can tell us whether the data are inconsistent with the null, okay? However, it cannot tell us whether the effect is important, meaning, let's say, economically important, whether the model is correct, whether the assumptions of the OLS are holding. Those require judgment and diagnostics, which you should have done before you then claim that, okay, I can use these standard errors in here to compute my test statistic out of which I will then have a decision for my hypothesis testing. So testing a single coefficient means comparing its different from zero to the amount of noise we expect under the null hypothesis. I hope this made a bit clear where some of the elements that you will see in the next video will be. In the next video, we'll turn this logic into a very clear step-by-step procedure, the t-test for the single coefficient from hypothesis to decision. Thanks for following, and I'll see you in the next video.